Okay, I want to talk now about the three errors that you can get with the marine sextant. The first one I want to talk about is what's known as the error of perpendicularity. Okay, now with the error of perpendicularity you have to hold the sextant horizontally. With this particular error we hold the sextant horizontally, and it's caused by the index mirror here not being perpendicular to the plane of the instrument. How we check that, our index arm, we move that about halfway and we turn the sextant round so that we're looking straight at the index mirror, and we look through the index mirror and we adjust our index arm until through the mirror we can see the true and the reflected arcs. So we need to see the true and reflected arcs of the instrument through the index mirror, and if those true and reflected arcs are not in line, then you have what's known as an error of perpendicularity. So you need to look through at the arc, and if they aren't in line, the arcs, it's an error of perpendicularity. To correct that, on the back of the index mirror there is a screw, and with your screwdriver there'll be a hole through the screw, and you can put your screwdriver through that hole and twist it one way or the other, and you do that and then check again the arc, and you keep adjusting it until the two arcs are, the reflected and the true arcs, are brought into line. So that's the error of perpendicularity. Okay. The second error we're going to talk about is the index error. Now the index error is caused by the index mirror, this one here, and the horizon mirror, the two mirrors, not being parallel to one another when the index arm is set at 0. So when our index arm is set at 0, the two mirrors have to be parallel to one another. So how do we check to see if we've got index error? Well, we set our arm at 0, so we have to be at 0, and we observe the horizon, and we hold the sextant vertically looking through the horizon mirror at the horizon. And we can see through our horizon mirror the true horizon through the clear glass, and the reflected horizon through the glass, the reflected glass, the mirror if you like. So we've got a plane and reflected, and we'll see two horizons. If the two horizons are completely level when they hold the sextant vertically, then you have no index error. However, if the two horizons are out slightly, then we have index error. To correct, we adjust the screw on the reverse of the horizon mirror, and it's the screw that's nearest the plane of the instrument. And it's the same principle. We get our screwdriver, put it through the little hole in the screw, and we can then turn the sextant back looking at the horizon with the screwdriver in, and as we're looking at the horizon we can then gently turn one way or the other to correct for index error. So that's how you would correct. You would simply move the screw until the two horizons were absolutely in line. One other way you could do this is simply to set your arm at 0, look at the horizon. If they're out, then adjust your micrometer until you get the two horizons in line. Once you've done that, that actually gives you the index error. An index error in exam questions or for practical purposes is named on the arc or off the arc. So if you had an index error on the arc, it means that the reading is to the left of 0 on your sextant. If it's off the arc, it means the reading is to the right. So that means that when you're doing your working out your sight, and you've got your sextant altitude, and you need to apply the index error, if the index error is said to be on the arc, you subtract it from your sextant altitude, because of course it's increasing the sextant altitude when you have an error on the arc. And opposite to that, of course, if the error is off the arc, then you add it to your sextant altitude to get your observed altitude. because it's actually giving you a slightly lesser reading of the correct sextant altitude. So that is what's known as the index error. Okay. Now the third error is known as side error. And side error is caused by the horizon mirror, this mirror here, not being perpendicular to the plane of the instrument. So now we're talking about the horizon mirror. And how we check that, we again set our sextant at 0 and we observe in the distance, holding the sextant vertically, we observed a chimney or a lighthouse. They'd be very good observations to make. The chimney or a lighthouse at least a couple of miles away. You need to be a reasonable distance. You set your sextant at 0, look through at them, holding the sextant vertically, and if you see more than one chimney, lighthouse, then you have side error. So if the reflection is blurred, if you see almost two of the objects, then you definitely have side error. How you correct that? Again, you get your screwdriver and you put it on the back of the horizon mirror, and it's in the little screw at the back which is furthest from the plane of the instrument, and you put that in, and then again you observe, holding the sextant vertically, you observe the chimneys or the lighthouse, and you move the screw slightly up or down until the chimney or the lighthouse you have just simply one. You simply see what you should see, and just simply one chimney or one lighthouse. When you correct for side error, what often happens is that you introduce a little bit of index error. So then you have to then check the horizon, and if the horizon is slightly out, you have to use your screw again to correct for the index error, and then go back and look through to see if you've now introduced a bit of side error, and it's just a case of adjusting each other slightly until you get rid of them. Of course, you can get rid of the side error completely and then simply look at the horizon for your index error and then allow that index error in your calculations. So just to briefly sum up, we have perpendicularity when we hold the sextant horizontally and look through and see at the arc of the instrument, and if the reflected and the true arcs aren't in line, then we have an error of perpendicularity. Then we looked at index error when we looked at the horizon through the glass, and then we have side error when we looked at the chimney or the lighthouse. And they are the three adjustable errors that you can adjust with the little screwdriver on your sextant.